Welcome to another explainer. So look around you for a quick second. That phone you might be holding, the medicine in your bathroom cabinet, even the internet keeping us connected right now, literally none of this exists without a few massive, monumental leaps in human understanding. Today, we're talking about the forces and formulas that actually define reality. We're going to take a journey from the invisible, foundational forces keeping our world spinning down to the microscopic building blocks of life, and then zoom all the way out to the infinite cosmic frontier. It's just a truly incredible story of how human knowledge has pushed way past what we ever thought was possible. But before we get to the massive scale of the universe, I want you to think about this. What if some of the greatest discoveries, the absolute game changers that permanently altered humanity, happened completely by accident, right? We usually picture science as this perfectly structured path, a genius in a sterile lab, crunching numbers, and boom, a eureka moment after decades of planning. And hey, sometimes that is exactly how it goes. But history actually shows us that sometimes the universe just hands us a clue, often hidden in a remarkably messy laboratory. Okay, let's dive into this and look at these two extremes. On one hand, you've got these lucky, accidental breakthroughs. Think of a stray mold just ruining a simple petri dish. That should have been a totally failed experiment, but instead, it literally changed the world. And on the flip side, you have these monumental, highly intentional triumphs of engineering, like giant particle colliders. Those take thousands of brilliant scientists and decades of meticulous, grinding research just to build. The crazy thing is, both paths, the lucky accident and the massive intentional grind, have been absolutely crucial for decoding the mysteries of our universe and creating the tech we use every day. Let's jump into Section 1, the forces that power us, the invisible engines of our world. All right, we've got to begin with gravity. Now, I want you to forget that whole myth about the falling apple for a second. Gravity is this fundamental, universal force that has been around long, long before humans were even here to experience it. What Isaac Newton actually did wasn't inventing gravity. He basically decoded the mathematical language of the universe's glue. He gave us the exact formulas to finally comprehend why massive planets stay perfectly locked in orbit around the sun. To really grasp just how huge this is, imagine if gravity just suddenly switched off. The stakes seriously couldn't be higher. Earth wouldn't even be able to hold onto its atmosphere. The very air we're breathing right now would just drift away into nothingness. Billions of gallons of ocean water would vaporize and float right into the vacuum of space. Life as we know it, gone, instantly. So understanding gravity wasn't just solving some abstract physics puzzle. It became the literal bedrock of modern physics. And, just like gravity, electricity wasn't invented by one person on a random Tuesday. It was actually discovered and pieced together through this thrilling historical baton pass by some of the most brilliant minds ever. First, you've got Benjamin Franklin stepping up, proving that the raw, terrifying power of lightning is actually electrical. Then he passes the baton to Michael Faraday, who takes that concept and builds the very first electric generators. Then Nikola Tesla steps into the ring and totally revolutionizes alternating current, which made it possible to actually shoot that immense power across vast distances. When you look at the sheer scale of what that historical tag team gave us, it's mind-blowing. Literally everything, from the lights in our living rooms and the life-saving machines humming in our hospitals, to our laptops, the rockets launching our space missions, and even the cutting-edge AI that's reshaping our future, all of it relies entirely on that specific sequence of discoveries. Without our mastery of electricity, modern civilization would just grind to a silent, immediate halt. Moving on to Section 2, the miracles of life, unlocking biology. This brings us to what's probably one of the greatest before and after snapshots in all of human history, and it comes from one of those incredible accidental discoveries we talked about earlier. Back in 1928, Alexander Fleming, who, by the way, was notoriously messy, came back to his lab to find a rogue mold had completely contaminated one of his bacteria cultures. But instead of just ruining his day, the mold was actively killing the bacteria. That little mold, that was penicillin, the world's first true antibiotic. Before that happy accident, getting a tiny scratch could literally be a death sentence. Today, thanks to Fleming's messy desk, millions of lives are saved every single year. Zooming in even deeper, we hit the ultimate biological breakthrough, DNA. Unveiled in 1953 by scientists James Watson and Francis Crick, this famous double helix structure is basically the ancient operating system running every single living organism on Earth. It is the literal physical blueprint dictating how life is built, from the smallest blade of grass in your yard to you and me. And cracking this one microscopic code set off a massive ripple effect across human knowledge. It completely revolutionized 4 major fields of study. In medicine and genetics, we can now actually spot and edit diseases right at their root code. In criminal investigations, it birthed modern forensic science, giving us undeniable biological proof to solve mysteries. And in evolutionary biology, we can literally trace our genetic code backward through time to study our ancient human ancestors. It's like a biological time machine. All right, let's zoom in even further. Section 3, Secrets of the Quantum Realm, Deep Inside the Atom. Let's talk about Henri Becquerel. He was studying uranium and completely accidentally stumbled into radioactivity, this incredibly potent force of nature just hiding inside the atom itself. He found something totally unknown, but it was Marie Curie who bravely grabbed that baton. She expanded the research and discovered entirely new radioactive elements. Working off each other, they unlocked a power that fundamentally shattered and rebuilt our understanding of what matter can actually do. Now, radioactivity has this terrifying but frankly incredible dual nature. Yes, it's extremely dangerous when it's uncontrolled, but look at what we've achieved by figuring out how to harness it. It's become one of our most versatile, powerful tools. It gives us the ability to treat aggressive cancers. It lets us generate massive amounts of electricity. We use it to power the probes exploring deep space, and we even use it to figure out the exact age of ancient Earth fossils. It's basically the ultimate example of science taking a dangerous mystery and turning it into an essential, everyday utility. Then, deep within that quantum realm, we find the Higgs boson, often called the God particle. Now, this wasn't an accident. This was the result of that massive, highly intentional effort we mentioned earlier. Finally confirmed in 2012 at the Large Hadron Collider, this discovery proved the existence of an invisible field that actually gives mass to fundamental particles. It is the literal reason why matter has physical substance. I mean, think about it. Without this tiny, microscopic mechanism, absolutely nothing physical could exist. Period. No stars could form, no planets would be out there, no humans. Confirming the God particle was easily one of the greatest achievements in modern physics, simply because it proved the very mechanism that allows our universe to actually take a physical shape in the first place. Okay, time to zoom all the way out. Section 4, the cosmic frontier, bending space and time. Out in the deep cosmos, gravity gets pushed to the absolute extreme with black holes. These are regions in space where the gravitational pull is so unbelievably strong that absolutely nothing, not even light itself, can escape. For decades, these terrifying, mysterious objects existed purely in mathematical theory. But then, in 2019, scientists pulled off an unbelievable milestone. They captured the first real, actual image of one. It was this supermassive monster 55 million light-years away, and it definitively proved that these bizarre engines of gravity, time, and space are actively out there, shaping how galaxies are born. Speaking of space and time, over a century ago, Albert Einstein made a wild prediction. He said that massive cosmic events would create literal ripples in the fabric of space-time. I want you to just sit with this awe-inspiring fact for a second. It took 100 years of human technological advancement to finally build an instrument sensitive enough to catch a wave that Einstein just knew was there all along. And in 2015, they finally detected them. Gravitational waves were real. This discovery unlocked a completely new way to explore the cosmos. Before 2015, we could really only see the universe using light. But now, with gravitational waves, we can essentially hear or feel it. We can detect incredibly violent, massive cosmic events that are completely invisible to standard telescopes, stuff like 2 black holes colliding in the dark or neutron stars smashing into each other. It has literally opened up a brand new sense for humanity to study the universe. And that brings us to Section 5, the never-ending journey. What comes next? So from the gravity keeping our feet firmly planted on the ground, down to the microscopic DNA blueprinting our bodies, and all the way out to the literal ripples of space-time, scientists just constantly revealing these mysteries we once thought were entirely impossible. Which leaves us with one incredibly exciting thought. What in the world are we going to discover next? The next impossible breakthrough, the next lucky accident, the next massive scientific triumph might be happening in a laboratory right at this very second.